Hello friends, now we'll start a new concept in chemistry called electrochemistry. Electrochemistry, that is how you are going to be produce an electricity by using some chemical compound. Simply we can say it is an electrochemistry, that is an production of electricity by using some chemical compounds. In this case, that is, we can explain that it is a relationship between the electrochemistry. We can say that it is a relationship between a chemical reaction and electricity, that by different types of chemical reaction it is going to be produce an electricity. We can consider it is an by different types of chemical reaction it is going to be produce some electricity, that is called electrochemistry. Previously we have discussed that if you are anything if you want to produce an electricity, definitely there should be production of some production of either free electrons or there should be production of free ions. Okay, so that means what I want to say here is, if you want to produce an electricity, say for example the light is glowing, the fan is rotating. Why it is rotating, why that is glowing? Because there is a flow of electricity. How you say that there is a flow of electricity? The flow of electricity can be we can say when there is a flow of electrons. If there is a flow of electron, then it will conduct the electricity. We can say that there is a production of electricity. Or if it is consisting of free ions, whether it may be the positive ions or negative ions, if it is consisting of free ions, we can consider it the electricity is producing. There is a conduction of electricity. Remember, if you conduct the electricity, must and should, there should be a production of either electrons or there should be production of either free ions. Here also in the same case, in the case of electrochemistry, we are producing the the free electrons or free ions during the process of chemical reaction. There is a production of free ions or free electrons, which by this production of free ions or electrons there is a production of electricity. This process of production of electricity by the chemical reaction, then it is, we can consider it as an electrochemistry. See now here, the study of production of electricity from energy released during the spontaneous reaction. Remember this point, spontaneous chemical reaction. Spontaneous, it does not mean that the reaction it has to be taken immediately. It is not the meaning that it has to be taken within a fraction of seconds. Spontaneous means generally naturally occurring reactions. We can consider that some chemical reaction is going to be happen, and this chemical reaction is going to be produce some energy that we are going to be consider it as an electrons or the free ions which conducts electricity, right? So the chemical energy we are going to be converted into electrical energy during this process of spontaneous reaction. That is a reaction, it is occurring spontaneously, the chemical reaction. This chemical reaction is producing the electricity, that is called electrochemistry. There is a production of electricity by the spontaneous chemical reaction, and this electrical energy it is utilized for any other purpose, that is they are called as a non-spontaneous reaction. Okay, this is, we can say that it is an study where we are going to be convert the chemical energy into electrical energy and electrical energy converted into chemical energy, that is in vice versa, chemical energy converted to electrical energy, then vice versa, that we can convert in both the cases. See, basically this electrochemistry discuss about the production of electricity by using some chemical reaction which produces the free electrons or free ions. Now we'll see the construction and some histories. Before going to the construction, we'll see some history when this electrochemistry, what are the contributions done by the different scientists in this area. In the year 1771, Dr. Galvani, he is the first person who introduced the concepts of electrochemistry, and he named it as animal electricity, right? Basically this doctor, he is a doctor, right? He is a doctor, belongs to biofield. He was the first person who introduced the concept called electrochemistry, and he named it as an animal electricity. Why he has named animal electricity? Because while he was taking the food, that is he was eating the frog, and this frog he observed that he has taken the fork, and while he was eating with his fork, there is a rotation, the dead frog, it is going to be rotate. That he observed that something it is happening inside the body of the frog. So actually the reason is here in this fork, it is consisting of that frog, the fork consisting of one kind of metal. Say for example it may be the it may be made up of iron, and another fork it may be made up of some other metals like aluminum or some other metals, whatever the. So there is a different different metals he has used. That one fork it is made up of iron, another fork it is made up of aluminum. This contact with these forks, there is some electricity, some production of electricity has happened. So the frog it is rotating. That is the dead body, that is a fried frog, it is going to be rotate. So that's why he observed, particularly in the case of animal, that is a frog while eating, so he named it as an animal electricity. Is it clear? So Galvani is the first person, of course he is a doctor, but he has first introduced the concept of electrochemistry and named it as an animal chemistry. Next one, Volta, right? Volta is the first built the first battery and named it as an voltaic pile. And after the discovery of this voltaic pile, he disproved that galvanic theory, that it is animal electricity, right? He discovered with the different kinds of metal by using some carbon and some cotton plugs, all these things he has done. The first battery has done, the primary battery has done by the Volta. It is called as an voltaic pile. Pile means an arrangement of coins like this in a form of like this. If you are arrange the coins or something in a systematic order in a one above the other, then it is called as a pile. Okay, so by the discovery of this voltaic pile, it was disproved that the galvanic electricity, that is an animal electricity, is disproved. Okay, in the year 1836, John Daniel invented the primary cell. We'll discuss about the what is a primary cell, what is a secondary cell, what is a fuel cell, all these things we'll discuss in this chapter. Next, in the year 1839, William Grew invented the first fuel cell. Okay, next in the year 1889, Nernst introduced the calculation of EMF, electromotive force. Electromotive force. He introduced, that is an what is an electromotive force, how you are going to be calculated, that we'll discuss in a continued class. Now, construction of electrochemical cells. Before going to discuss what is an electrochemical cell, before going to construction, we'll discuss what is an electrochemical cell. See, remember carefully, electrochemical cell means the cell which is useful for the production of electricity by using chemicals, right? We are taking some chemicals, from these chemical we are producing some electricity, that it is called as an electrochemical cell. There is a difference in this one. Again, one more cell called as an electrolytic cell. Here in this case, electrolytic cell means, see, electrolytic cell means we are utilizing the electricity, right? We are utilizing the electricity for the process of chemical reaction. That's why in the beginning only I told you that is an electrochemical process. It is an conversion of electrical energy into chemical energy, and chemical energy is converted to electrical energy. There is a vice versa between the electrical and chemical energy. Okay, anyhow, coming to the point of what you call electrochemical cells, I told you electrochemical cells, we are utilizing some chemicals, right? Production of electricity by using some chemicals, right? Then it is, we can consider it as an electrochemical cell. Electrochemical cell, right? For example, we can consider it as a Daniel cell or voltaic cell. All these are considered as an electrochemical cells. And this is a spontaneous reaction that we are using the chemicals, natural chemicals, that it is going to be produced, what do you call, then a spontaneous reaction, right? Next, electrolytic cell, the electricity produced non-spontaneous reaction. That means we are using electricity for the process of chemical reaction, right? See, from the chemicals we are producing electricity. This type of cell where you are using the chemical energy, that means the chemicals to produce electricity, it is called as an electrochemical cell, right? And the electrical energy, it is useful for the process of chemical reaction. That is, electricity, we are using the electricity for our chemical reaction. Then this process of utilization of electrical energy to convert into chemical energy, we are converting, it is considered as an electrolytic cell. There is a difference in the electrolytic cell and the chemical cell, electrochemical cells. Okay, next, construction of electrochemical cells. See, I told you already, the electrochemical cells means which is useful for production of electricity. Now, a simple way, construction of electricity. See here, it is consisting of a glass plate, a glass beaker, and this glass beaker, it is consisting of a liquid solution and one metal electrode. Here also the same liquid solution, different types of liquid solution in A and B, right? The reactant 1 and the reactant 2. Okay, so now these two metals, it acts as an electrode in this beaker, and this metal, it acts as an electrode in this beaker. These are connected to the positive and negative terminal of a battery. Now, this complete circuit, it is indicating here. Now, one more thing, it is provided here, which is called as a salt bridge. What is a salt bridge? We'll tell you one by one. Okay, here in the case of the first, consider I'll consider it as an A, it's a B. Okay. A1 consisting of chemical C, the chemical nature here, the liquid content here in both the cases, we are considering it as electrolytic solution, electrolytic solution, or simply we can consider electrolyte. Okay, here also this is an electrolytic solution, here also it is called as an electrolytic solution, and here it is a metal, right? Here it is a metal. Okay, now this is first, you see, in this case here it is consisting of, I'll draw that one. See what is happening here actually. Say for example, I'll take one electrolytic solution here. This is my electrolytic solution, and I'll place one metal rod in this one. Okay, I kept the metal rod. Okay, say for example, I have taken a zinc here, zinc metal, and this is considered, you consider it as a zinc sulfate solution. So I can say now the zinc metal I kept here in the zinc sulfate solution. What actually happening here, right? That we'll discuss here. What is happening actually? See, the zinc, it is a metal which is consisting of zinc atom. It is in the form of atom. See, basically we have discussed in the previous slides that atom is a neutral, right? That is consisting of number of electrons, and the protons is same. Okay, so whenever, see, the zinc metal, it is consisting of zinc atom. Here the electrolyte, it is consisting of salt solution. These zinc sulfate, right, in the solution, it will be in the form of ions like Zn2 plus SO4 2 minus. Well, so now it is in the solution, it exists in the form of positive ions and the negative ions. What is happening here actually? If you observe carefully, the zinc metal consisting of zinc atom, it will try to donate its electron, right? It will try to donate its electron, and this zinc in the metal, it is try to donate the electron, it will be converted to Zn2 plus 2 electrons is donated. See, zinc, it is donating 2 electrons, right? Donating 2 electrons, it is converted into, it will try to convert into Zn plus ions. That means, see, now I'll write again. So this is my zinc metal. Now this is the solution or electrolytic solution which I kept here. Okay, now what is happening, we'll see first. See, I told you the zinc metal which is present here, it will try to donate its electron, it will try to donate its electron, right? It is converted to Zn2 plus ion. Okay, so that is donating the electrons, right? At the same time, the Zn which is present here, Zn2 plus ion which are present here, it will try to accept these electron, it will try to deposit on this one, right? Simple. Zinc, it will try to donate its electron, it is converted into Zn2 plus ion. At the same time, Zn2 plus ion which are present in the solution and which are coming from that one, it will try to accept 2 electrons and it will try to deposit in the form of zinc on the metal plate. So there occur a potential, right? There occur, that is an what you call the donation of electron and accepting of electron. There occurs a difference. This is called as an electrode potential. Electrode potential. So in this way there occurs some production of electrons, and this difference in this electron, that is an going of donating of electrons from the zinc atom of the zinc metal, and Zn2 plus ion which are present in the electrolytic solution, it will try to accept the electron. There occur a difference that is called as an potential difference. Now we'll see in this case what is happening here. See, in the first case the reactant, see in both the cases the thing is the same, that I have taken with one example as in zinc metal. In this case also that metal, for example, whatever the X metal, whatever the X solution, right, Y metal and Y solution. So if you are taking the one type of metal, the same type of solution we are going to take. Here also the same, one metal and the same type of the solution. Okay, so say for example I'll take X metal, here I'll take the X type of solution, Y metal, Y type of solution. Okay. Here in this case the first one, that is in reactant 1, contains here, this is going to be donate. Generally the metal electrode in general case of electrochemical cells, the metal this is completely called as an what do you call a half cell. Okay, so this half cell, it is consisting of, it is involved in the property called oxidation, right? Oxidation, right? In this case the electrons are going to be donates its electron. The electrons are going to be donates its that's the metal which is present towards the left side, it is going to be donate this electron. These electrons which are donated here, it will transform from these see, I told you in the beginning that this these 2 beakers, it is connected to the battery, that this is connected to this battery. Now it is going to be transfer the electron, and this electron it is passing, and the current it will flow in opposite direction. The electrons is moving from first reactant to the second reactant, and here the electricity will flow in opposite direction. Electricity will flow in opposite direction, right? How it is possible? We'll see. In this case, for example, I'll take here, this is considered as a zinc metal, and now it is considered ZnSO4 solution. Okay, now I'll take here is in copper metal and copper sulfate solution. One more thing I want to tell you here. Here the left side one, it involves in the process called oxidation, and the right side one it involves in the process called reduction. Hope you know that is what is an oxidation and what is a reduction. We'll see first. Oxidation means oxidation. Right? Increase in the oxidation state, increase in the oxidation state, or addition of oxygen, or loss of electron. Simply we need only one definition here, that is enough, loss of electron. Simply to remember LEO. LEO means, that is loss of electrons is called oxidation. Loss of electrons is called oxidation. So oxidation means the loss of electron. Here it is going to be loose by the process which, if it is involving any metal or anything which involves in the oxidation, means it loses its electron. Loss of electrons, it is called oxidation. Now we'll see reduction. Here also we are having many definitions. Opposite to this oxidation, it is called reduction. Here I said it is an increase in the oxidation state. Now we can say it is an decrease in the oxidation state. Here I said addition of oxygen. Now I'll say removal of oxygen, right? I said reduction mean loss of electron means oxidation. Now gain of electron, gaining of electrons is called reduction. We can remember, see this is GR, reduction. Simply to remember this one, both the oxidation and reduction, Leo says GR. That means loss of electrons is called oxidation, gain of electrons is called reduction, right? Leo is what do you call it? He is grumbling that sound, it is like that. So here you can remember like this, that is GER. That means it is giving sound. Okay, so gain of electrons is called reduction, loss of electrons is called oxidation. You may get this question, what is an oxidation, what is a reduction? The process of gaining of electrons is called, you may get the question, that is process of gaining of electrons, it is called reduction. The process of losing of electrons, it is called oxidation, loss of electrons. Now we'll see. So I told you, generally in the case of here, what you call, we have taken this zinc metal, right? Here the zinc metal, and we have kept in a zinc sulfate solution. We have taken copper metal and copper sulfate solution. Now I told you which is present at the left side, the first reactant, it acts as an what you called, losses of electron, loses its electron, right? Oxidation, it occurs in the oxidation. Okay, so now this, what is happening here? The zinc, it is going to be donates, the zinc is converted into Zn2 plus ions plus 2 electrons. So whatever the electrons it is going to be donated, it is going to be passed from here, right? Here I told you it is involving in the process called oxidation. Okay, oxidation here. So the 2 electrons which are passing from here, it will transfer to this metal. So here the copper, this copper, see, okay, this copper metal, what it will do, this copper metal, it will accept the 2 electron, it will accept the 2 electrons, it will try to convert into copper plus 2 ion. See, remember, this is an copper metal, it is accepting the electron from here, and now this the copper ions which are present here, this this copper which is present here, it is going to be donate its electron. It will accept the electron from the zinc what it is getting. So the Cu, it accepts the electron, 2 electrons, it is converted to Cu2 plus. Well, what is happening here after the donation of these electrons, it is passing from zinc and it is transferred to the zinc, a copper metal, and this copper metal, it is accepting the electron. Accepting of electron means it is a reduction process. So here it is an oxidation, here it is occurring the reduction process. So here gaining the electron, it is called reduction, and losing the process, it is called as an oxidation, right? So this is here oxidation, it is considered as an anode, here it is an anode, and here it is called as an cathode. Remember, at the anode you are going to get the oxidation, anode, at the place of anode oxidation will take place, oxidation, and at cathode what it will do, it will take reduction, right? To remember, this is very important. Anode, which acts as an anode, and what do you call, what is happening in the case of electrochemical cells, what is the process occurs in the case of anode. So anode at anode oxidation takes place, and at cathode reduction will take place. Simply to remember, an ox, you remember that is an ox means anode oxidation takes place, red cat, that is an reduction takes place at cathode, right? Like this you can remember. There may be probability of getting the question in the case of the electrochemical cells, the oxidation takes place at anode, cathode, right? Like that. So oxidation takes place at anode, reduction takes place at cathode. Okay, so oxidation means here it is losing the electron, right? Whatever the loose electron, here in this process of the reduction process, it is going to be accept this electron, it involves in the process called reduction. Okay, now after the reduction, see, now I told you that the electrons are going to be moved from here, and it is moving to zinc, copper, and this copper is accepting, and this what you call the copper ions are going to be released here. That is, by accepting the copper, by accepting the 2 electrons by the copper, it is going to be converted into Cu2 plus ion, right? And I told you that the electrons are moving and the current flow in opposite direction. Okay, now the thing is, what is the use of salt bridge? What is a salt bridge actually? Salt bridge, it is an U2 which is consisting of, generally this salt bridge, it is consisting of only the inert material, salt bridge, salt bridge, it is consisting of generally it is consisting of agar-agar and some potassium chlorate, right, or potassium nitrate, or some sulfate content, potassium sulfate content, okay, sulfate content, like this. It is consisting of some chemicals. This salt bridge, what is the use of this salt bridge? Generally, I told you that in salt bridge it is an inverted U-type structure. It is consisting of agar medium, which is mixed with this kind of solutions, these kinds of chemicals. Now, what is the use of this salt bridge? Salt bridge, it maintains the neutrality. It maintains the neutrality in both the cases of electrolytic cell, that is an half cell and half cell. See, what is happening here? In the case of the zinc, if you observe carefully, here the zinc, it is going to be donates its electron, that it is 2 electrons are going to be donate, it is converted into Zn2 plus ion. So this Zn2 plus ion, it will become more quantity, that is in Zn2 plus ion, it will be increases in this case, correct? The Zn2 plus ion concentration will be increases. See, basically we have taken zinc sulfate solution previously. So this zinc sulfate solution, it exists in the form of Zn2 plus ions and SO4 2 minus ion. So zinc sulfate, it exists in the form of Zn2 plus ions plus SO4 2 minus ions. But during the process of these electrochemical cells, what is happening here? So the zinc, it is going to be donates its electron, it releases Zn2 plus ion. So this Zn2 plus ion quantity, it is increases here. So again in the same case, the what you call the copper ion, it is accepting the Cu2 plus ion, it is going to be converted, the Cu2 plus ions, it is going to be increased to, in order to maintain the neutrality, that here the sulfate ions and the zinc copper ions and sulfate ions and all these things, it is maintained the neutrality by the salt bridge, that is, it is passing the sulfate wherever it is required, it is passing the ions, positive ions wherever it is required. It maintains the neutrality. Salt bridge, it is an inert medium and it maintains a neutrality, right? So here remember the major concept in this case of electrochemical cells, right? Electrochemical cells, where you are going to be produce the electricity by using the chemicals, right? So if you are using this one, what you call if you are using the zinc as an anode, and if you are using the zinc as an anode and copper as a cathode, right? Copper as a cathode, then this type of cell, it is called as an Daniell cell or voltaic cell, right? And it is consisting of 1.1 volt, right? That it is going to be produce a volt of 1.1. That means it is an zinc, copper, it is connected to get the deflection, I mean to say that electricity is produced or not, all these things. And here it is an electrolytic solution, it is copper, it is copper sulfate, it is zinc sulfate. Okay, so now what is happening? The process, that electricity is going to be conducted, there is 2 electrons is moving, 2 electrons are moving from here, right? So the current flow in opposite direction, current is flowing, that means its volt is 1.1 volt. Okay, so anode, it is an anode, it is a cathode, anode, it is a cathode. Okay, so what is happening at the anode? Anode, it occurs oxidation, right? Here it occurs reduction. Okay, so the electrons are moving and it will conduct the electricity. This in order to maintain this neutrality, it is connected with a salt bridge to maintain the neutrality, which is inert medium. Okay, that is something about the what you call electrochemical cells, and it is going to be produce a potential difference. Already I told you how it is going to produce the electrode potential, right? Now we'll see some of these batteries called primary batteries. That is by studying all these things, we are having the different kinds of batteries. We have invented the different types of batteries. These batteries are classified into 2 types majorly, primary battery and secondary battery. Primary battery means the battery which is used only for one time. That means once if it is an we can use only one time. That means once if it is an expired, we cannot recharge that one, right? Primary, this is called as a primary battery. We have classified into two types of battery, primary battery and secondary battery. Secondary battery. See, the best example in the case of the electrochemical cells, we can say that what do you call, that is mobile batteries and watch batteries and what do you call, toys, the batteries, all these batteries will comes under this, under electrochemistry only. But some batteries which are going to be rechargeable, which are not going to be rechargeable, we have classified into primary battery and the secondary battery. Primary battery which is not rechargeable, once if it is used, we have to throw it. There is no use of that one, that we cannot recharge that one and we cannot utilize for the next time, right? Whereas secondary battery, that is a rechargeable battery. Say basically we are using the inverters we can consider under the secondary battery, right? Primary batteries, that is which are used in the radios and watch glass, wrist watches or wall clock, all these things we are using the primary battery. Okay, so now in this case of this primary battery, here one example of this primary battery, this primary battery, it is consisting of what do you call, carbon graphite, that is a graphite rod which acts as a cathode, and the complete, it is made up of zinc tin which acts as an anode. This is very important. Zinc, it acts as an anode, and here the graphite, it acts as a cathode. See, which metal generally you may get the, which metal it acts as an anode in the case of primary battery, or in the case of the battery generally we can consider zinc, it acts as an anode, and the graphite, it acts as an cathode. See, in the case of any kind of electrochemical cell, there is a compulsory requirement, whether it may be primary or secondary, there is a compulsory requirement of what do you call, electrodes, anode electrode and a cathode, right? Along with that, it is consisting of electrolytic solution also, right? Electrolytic solution. Or electrolytic solution, it does not mean always it should be in the form of a liquid. It may be in the form of paste. For example, here also I am telling, this is our anode and this is our cathode, and now this is our electrolyte which acts as an electrolyte. That is this electrolyte consisting of manganese sulfide, zinc sulfide, ammonium chloride, and also some content of carbon, which is in the form of a paste, not in the form of a liquid. If you break the battery and if you observe that one, you can clearly observe the graphite rod and some paste like substances inside this battery, right, which acts as electrolyte. And now this paste, it is consisting of, what is the paste consisting of? Manganese dioxide, zinc sulfide and ammonium chloride. So now here the negative terminal and the positive terminal, right, now it acts as a battery. It can be utilized for the production of electricity. You will not get the electricity like 100 volts, 200 volts. That's a minimum quantity of the energy you will get. So this primary battery, it is also considered as a Leclanche cell. Leclanche cell we can consider as a first discovery of primary battery, that is called as a Leclanche cell. Now major concept here you have to remember is which acts as an anode, which acts as a cathode, which is act as an what do you call, electrolyte. The paste of MnO2, ZnCl2 and ammonium chloride and carbon, it acts as a the paste of these, everything, it acts as an electrolyte, and graphite acts as an cathode and zinc acts as an anode, right? Next one, secondary battery. Secondary battery, I told you that is a secondary battery, it is nothing but it's a rechargeable battery. Rechargeable battery, right? We can recharge. Once if it is an or then again it can be recharged. Say for example, our lithium batteries which are present in what we are using in the mobiles, that it is completely rechargeable batteries, that it is consisting of majorly the lithium content. Okay, now this is we are going to be provide the electricity. That means electrical energy is converted into chemical energy. It is saved in the form of chemical energy. Now whenever you are going to be remove the charger, what is happening? The chemical energy, it is useful for the production of electrical energy. Here also the same, the inverter what are using, the inverter, it is consisting of the chemicals, and whenever you are going to be apply the electricity, it is going to be recharge itself, it is going to be charging, right? Once if you remove the charger itself, it produces the electricity, right? So basically this rechargeable battery, it is consisting of this and lead sulfide battery. It is consisting of sulfuric acid, around 40 to 48% of sulfuric acid it is present, and it is consisting of lead oxide, lead insulating case, negative positive ion, there is a common which is going to be connected for the passage of the electricity. Major thing that it is consisting of sulfuric acid, right? So which acid is present in the case of secondary battery? That is sulfuric acid, but it is not 100% pure one, it is a diluted one, 40 to 48 or 50% diluted sulfuric acid you are going to be used in the rechargeable battery. The next kind of battery it is called as next kind of cell it is called as fuel cell. Fuel cell, the use of the fuel cells, majorly the use of the fuel cells to reduce the pollution content, right? So now in this case of the fuel cells, we are going to be use what are the products which are obtained by the process of combustion, right? So in this case, the fuel after combustion we are going to be passing this one, and particularly this methane and hydrogen gas we are going to be used, and this is involving the process of oxidation and the reduction process. It is going to be utilized. It is going to be utilized for the production of electricity without any wastage, right? Generally, this fuel battery it is used in the case of the Apollo Space Center also. Apollo Space Center, we are using this hydrogen fuel battery or methane. Generally, we are using the methane and the hydrogen gases for the production of these electricity by using the fuel cells. Okay, this fuel cells it is used in the Apollo Space Center, and very benefit of this one in the case of the Apollo Space Center that they are going to be produce a water molecule also by using these fuel cells. Next, some of the important bits which was asked previously in the case of this electrochemistry. Let us see what are the things what we have discussed or what we have not discussed we will cover in this area. Now, anode is a dry cell, the anode in a dry cell consisting of, right, the dry cell, I told you already that it is consisting of zinc, right? Zinc acts as an anode and the carbon graphite it acts as an cathode. Galvanization, it is the process of deposition of zinc on the iron. What is a galvanization? We'll see. See, during the process of electroplating, hope you remember, you know that what is an electroplating. See, gold coating and chromium coating, all these things we are considered as an electroplating. Likewise, here galvanization, it is a process where you say, for example, it is an iron rod, and this iron rod, if it is exposed to the atmosphere, it will cause a rusting. In order to avoid these rusting, you are going to be coat a layer. You are going to be coat a layer. This coating of layer, right? That is, we can consider as an electroplating. Particularly for the iron, if you are going to be coat a layer of zinc, that is an coating a layer of zinc on or iron, this process it is called galvanization. How you are going to do the galvanization? It's the same process what we have discussed in the preparation of electrochemical cells. That is in the case of see, I told you that one zinc is going to be deposited on the iron rod, right? Slowly it is going to be deposited by the process called electroplating. It is also useful. I'll give you some brief idea. Okay, so now, for example, consider it is some impure metal. I want to separate this impure metal impurities from this metal, and now I'll take a pure metal of this one. For example, for example, I have taken this copper ore, consider it as in copper ore. Okay, now I have taken a copper metal, it's in pure form. Now I am connecting to the battery. Okay, connected to the battery. Now what is happening after connecting of the battery? This already it is having the salt bridge, everything is there. So now what is happening? Slowly the electrons are going to be this this is going to be passed from here, and it is going to be deposited the impurities it is going to be deposited as an anode mode, and this copper ions it is going to be passed from here and it is going to be deposited. It is going to be deposited, and it will become this will become very thick one, this will become very light one. See, the thing is the concept what I want to present here in the process of oxidation. This is passing from here and it is going to be deposited on the copper plate, the pure one, and the remaining impurities it is deposit as an anode mud by applying some electrical current. Okay, so this is called as an electrolytic refining, and the same thing we are doing in the place of this copper metal. If you are going to be place a we are depositing the zinc or anything what you are going to be chromium, or we are going to be deposit on this one by this process. Okay, now we'll say this galvanization is a process of coating of zinc over the iron. That is on the iron we are going to be coat with one layer. That layer, if it is in zinc, then it is called galvanization. The process of coating of zinc over the iron, it is called galvanization. Acid used in the lead storage battery, I told you it is an sulfuric acid, right? The cathode in the lead storage battery, this is lead. Lead, it is used as a cathode. Next, then anode is in carbon. Now the metal exposed to the atmosphere, which will become green in color, it is there, which will become green in color, right? Which is, see, if the metal, if it is an exposed, yeah, right. Okay, see, if the metal, say for example one X metal is there, if it is an exposed to the atmosphere, if it is going to be get rusted, then blindly we can consider it is an iron. At the same time, the some X metal, if it is exposed to the atmosphere, if it is converted to green zinc green color, then it is considered as an, what do you call it, is an what do you call it, it is copper, right? It is coated as a zinc carbonate, and it is an copper, it is converted to green color, right? Whereas an iron, it is going to be rusted, right? That is in brown color. The material used in the electric current, it is a nichrome wire. This should be remember. Metal used in the electroplating, I told you the chromium, copper, nickel, it is used. And the anode in the dry cell, already it is repeated one, the zinc. And in the semiconductor, we are using the germanium. The solar cell, it is consisting of zinc cells. Next, one more thing I want to tell here, that is in the case of the primary battery, that here we are having another kind of battery called button cells, right? Button cells means which are used in the watch, wristwatch, okay, wristwatch, or you can use in some toys also, right? This button cell, it is consisting of anode acts, one second, okay, button cells, anode, in the case of the button cell, it is consisting of anode in the form of zinc amalgam, right? Mercury, it is called as an amalgam. Mixture of zinc with the mercury, it is called as a zinc amalgam, acts as an anode. And in the case of button cell, it is consisting of cathode, it acts as an mercuric oxide plus carbon, right? It acts as an cathode, right? And what is an electrolyte? Electrolyte here in this case, it acts as an consisting of potassium hydroxide plus zinc oxide paste, the paste of potassium oxide, right? So in the case of button cell, it is also called as a mercury cell, right? Hg is nothing but the mercury cell, okay? Mercury cell, the mercury cell, that is which is we are using in the case of watches. It is consisting of anode, zinc acts as an anode, and the carbon acts as an cathode. Electrolyte is an potassium sulfate and zinc sulfate. This is also a primary battery which cannot be reused. Why? This cannot be recharged. Okay. So zinc amalgam means the zinc with the mercury, it is called as an amalgam. So zinc with the amalgam, mercury, it is called as an zinc amalgam. It acts as an anode, and the cathode, it is an mercuric oxide plus carbon. Electrolyte, it is KOH plus ZNO paste, the paste of these one. I told you these are the must and things which should be there in the case of electrochemical cell. So there is the information regarding your electrochemistry. Thank you.